of solving project order solutions, and as you can see, we have solved 46 problems so far, and we want to solve a few more. Today we'll probably solve 1 or 2 problems depending upon how difficult the problem is. If you like things like this, then please remember to like and subscribe. It definitely helps the channel. But without further ado, let's start the problem. So like always, let us create a new Python file. We'll call it problem 47. Problem 47, and let's copy the problem. I see some prime number, so probably we'll use the sieve algorithm again. And let's see what the problem says. Okay. All right. So the first 2 consecutive numbers to have two distinct prime factors are 14 and 15. So that's a number 14, and that's another number 15. 2 consecutive numbers, so 14 and 15. All right. To have 2 distinct prime factors. Okay, so 2 and 7 are 2 prime factors, 2 different prime factors. 3 and 5 are 2 different prime factors. I don't know if this and this has to be different prime factors as well. Oh, okay, no. So there's 2 over here and 2 over here. So these 2 don't have to be different. So this and this separately has to be different among themselves, and this has to be separately different among themselves, and there has to be 2 prime numbers over here, 2 prime numbers over here, and these have to be consecutive. Okay. And then for 3 it's like that. Okay. Let's see how do we solve this problem. Okay, let me check out my iPad to see if there are some simple ways of solving this problem, or maybe not. Yeah, let's think about it. Let's think about how we can solve this problem. Let me connect. And let me open this, and let's try. Let's see what we can do with this. I have no idea. Okay, so we have a number. So we have a number n, and we have a number n plus 1, and we need the prime factors of this. So if we already have a list of prime numbers, then we can find the prime factors of this very easily, and we can find prime factors of this very easily, and then we just brute force it. So that's the brute force way. Is there some elegant way of solving the problem? That's the key. So let me see. So obviously these are composite numbers. So these are composite numbers, and they cannot be prime numbers because they have to be composed of multiple composite numbers, multiple primes at least. So if this is a prime number and then these are composite numbers, and this is a prime number and then there are composite numbers like that, then the distance between two has to be greater than 4, right? So prime 1, prime 1, prime 2, there should be a gap of at least greater than 4 between two prime numbers, otherwise yeah, there isn't really any way of squeezing in 4 composite numbers between them. So we need that to begin with. Okay, so I don't even know if that is a meaningful thing to look at. Other than that, these composite numbers must be made of at least 3 of the primes. So if I say this is pi and this pj, there should be at least 3 primes, 4 primes in this case, 4 primes in this case before that will allow you to create this number. Okay, these numbers. And what is the first of these 3 numbers? Okay, and anything else that we can think about? Yeah, I just can't think of an easy way to solve this problem. This one will have let's say this is made up of I don't know. I have no idea. Let's brute force it. Let's first brute force it, and then we'll figure out whether there are any other solutions to that. Okay. So let me try something. So we are going to start by creating a list of prime numbers, and then after that we will go ahead and see whether we can get better solutions. So prime numbers up to, what is this, 644. Let's get prime numbers to, I don't know, 100,000, 500,000. I think in the previous episode we got prime numbers to 500,000. 46. We got prime numbers to 100,000 and it was pretty fast. And you know what, let's copy this code. This is just something that we do to get prime numbers. And 481 milliseconds, half a second to get 500 prime numbers. And let's look at convert them into numpy arrays, and we don't need this anymore. Okay, so we have a list of primes. Length of primes, we have 9,000 primes. So now what we want to do is, there are different ways of creating numbers, but we want to find the prime factors. Okay, of a particular number. So let's write a function or which will return the prime factors of a number. So a number is given as n, and given a number which is an integer, it will return a list actually from it will return a list of integers. Okay, and the list of integers is going to be a set of prime factors. And the important thing is that we don't really care about. So for example, for this, we know that 2 is a prime factor, 7 is a prime factor, and 23 is a prime factor. We just need to know that we just need to know 2, 7, and 23. We don't actually have to look at every single factor, as in we don't have to figure out this is a factor of 4, 2 squared. So we just need 2, 7, and 23. So it's just a list of factors. So we'll start with an empty list like that, and then after that we'll keep on adding the factors. So for p in primes, okay, if p n percentage p is 0, then result dot appends p, and if p is greater than result, then just break. The other thing you want to do is, if n in primes okay, return n. So you don't have to go through all of this if it is a prime. So that's good. So let's look at 14 and 15. Prime factors of 14. P is greater than n. My bad. Prime factors of 14 is 2 and 7. Prime factor of 15 is that, and prime factor of 644 is alright, and we basically need to actually not worry about the results like that. So we just need the length. So instead of giving a list of prime factors, we will just return the length, and so this will be 0, this will be 1, and at this point result plus equals 1 and return result. So if we do that, then this is going to be 3, for n in 644, 645, and 646, like that. Okay, print n, and that is going to be that. All right. Okay, So now find the first 4 consecutive integers to have 4 distinct prime factors each. So they have to be exactly equal to 4 different prime factors, I think. Okay, so given what we have, all right, it has to be greater than this, obviously, because why not? So we're going to start at 646 and we're going to get, okay, so let's run a for loop for n in you know what, I should do a deck. Python from so let's say if I have a deck empty deck and max, I think it's max len is 4. I need 4 of these things. D equals that, right? And for I in range 100, okay, d dot append I and print d. So it's going to keep the last few results. Okay, so then what I can do is, if I start from 600 and I start with this, right, and so let's see whether we can find the case for n equals 2, right? We're going to start from 2, obviously, and we're going to go all the way to 100, and we will append, and we'll call this n, and we are going to append, and this is going to be n, prime factors of n, prime factors of n, like that. Okay, so that's that. We are going to print n and d, and let's just take a look at it. Okay, f Okay, so let's see what happens when we go to 14 and 15 over here. 14 and 15, so we have 2 and 2, and at this point where we have, okay, 2 and 2, and this is the first time we get 2 and 2, right? Okay, then we have to go one below because that's 14, and we have to return that number. And how do we make sure that it's 2 and 2? We just sum them up. So if it's 2 over here, 2 over here, if you add all of them up, we are supposed to get a 4. So can we sum the deck over here? It's 4, yeah. This is going to be the breaking condition. All right, sum D is SD, and we'll say SD, and if SD equals n, which is 2, times, so this one is going to be 3 times 3, 369, n squared. So this has to be 3, and this has to be 3, and this has to be 3, and in case of 4 it has to be 4, 4, 4, 4. Okay, so if that is the case, then wait, it can add up to 2 in different ways, right? So 3 and 2 can give, okay, so we don't want that. We don't want the sum of D. This is quite useless. We need to say D we want to check if D equals n times n, and at 15 it's false. List of that, is it true at 15? It's true at 15. It is also true at 21. Okay, but the first time it's true is at 15. So like that, right? If that, right, what the hell is this? Give me a sec. If that, so the first time that happens is at 15, right? And we want to break at this point. We don't want any more of these values, and we also want to print whatever the value of n is minus n minus 1 minus n plus 1. plus 1. So if we do this for 3 and we go all the way up to 1000, okay, we get 644, which is what we want. Okay, and currently we can only go all the way up to 100,000. Actually we can go more. Not that. So this is 100,000, and we want n equals 4, and it's taking a long time. Stop it. Factors. Let's see how fast we are going. Okay, so instead of going to 100,000, let's go to 1,000. 1,000 happens pretty fast. 10,000, and we know that there's nothing all the way up to 1,000. So 1,000 to 10,000, nothing. 10,000, 10,000 to 100,000. Do we even have 100,000? That's 100,000, yeah. If this doesn't work, then we need to increase I don't even know this is the right way of doing things. Wow, nothing. I need more primes. Like 100,000 won't work. I'm pretty sure I'm Beyond this, I need to multiprocess. Nothing till 100,000. Okay, let's get more primes. 100,000, half a minute. That's, what is that, a million? That's a million primes. This should take about 20 seconds to complete. And so now I need to go from 100,000 to a million. This is going to take a long time. I'm not doing something correct. Okay, so 25 seconds. Let me convert it into a number array. I am not doing something is not correct. So I'm going from 100,000 to a million, I think. Something is not correct. I need a better solution. Okay, let me think about it. It's already over a minute. It's not. This is not the right solution. Okay, let me think of. Let's go back to the drawing board. Doesn't look like this is working. Okay. Okay. All right. So, do we just get the solution? Is this the answer? That is the answer, but this doesn't look like the right right way of solving this problem. So we have to, it took 2 minutes and more than that 3 minutes to solve the problem, and it shouldn't take 3 minutes to solve the problem. All problems should be solved within a minute ideally. So I'll have to come back to this problem. I'll have to come back to this problem and figure out why this is the way it is. But for now, this is the solution. So I'll stop over here, and I will see you next time. And if you like videos like this, please remember to like and subscribe. And yeah, take care. Bye bye.